Hello. Hi guys, good morning. Welcome back to a new video. And oh god, this question is not at all medium. It is also not hard also, but yeah, I'll say it is a medium hard and towards a hardish just because of the problem statement, how they have framed it. It is actually a bit tricky and also it can be a bit tricky to understand the problem itself. Cool. Let's start off. It has been asked by in the weekly contest of number, I forgot the number, but yeah, cool. Let's start off the problem statement. Earliest second to Mark Indices I. Now there's Indices II also, that also we'll bring off. It is much harder. It's just a slight modification of the question, but yeah, because of that it has become much harder. So this says that you are given again 1 and 2 are not only because of constraints. It is not that okay 1 and 2 are just different because of constraints. There's also one statement added into which makes it a different problem, so we will have a different video for that. Again, in this we will see two improvisation of that, one like normal approach and the next one most optimized approach we will see. So it says that we are given two one indexed arrays. Now the worst part is they have given us one indexed arrays. Usually we work on zero indexed arrays, but now they have given us one indexed arrays, which can be a bit tricky to handle. But yeah, we have nums and change indices. These are two arrays which are given. So you can see nums and change indices. These are two arrays which are given. Size n, size m, size n, size m. Please keep on understanding the question because it is a very tricky to understand the question itself. Now, initially all the indices and nums are unmarked. So you can just imagine that in your nums, all of them are unmarked. So whenever I say it is marked, I will just put a tick. Okay, it is marked. It is marked. So initially you will see that all of them are unmarked. None of them are ticked. Okay, great. Now in each second s, so we have defined in each second s in order from 1 to m. Now you will see the 1 to m is the indexes of our change indices. So I'm kind of saying my each second represent, I'm going on each index of my string of my array change indices. So I can say okay, 1 to m is the each second, and that each second, and that each second is just representing, okay, I'm going on the m values. Okay, and what I can do is I can perform one of the following operations. Now this also makes sure that you can perform just one of the operations. You cannot perform both of them. This will also play a very important role, that you can only perform one of the operations. The operation is that either I can choose any index I in the entire range of nums and can decrease the value of nums by 1. So I have the entire power that at any second I can choose any of the values in nums. Again, no matter what, if I have chosen that before or not, if I have this new value, I can choose it any way whatsoever. I will choose that specific value and I will decrease the value by 1. Other option is that I can grab nums of change indices of s. I'll tell you what this is. And if it has become equal to 0, I can mark that index as okay, marked. It means by as in the beginning I showed you, as s is going on in the change indices array. So you can just imagine s as the index of your change indices array. Now s is the index. So s is the index. So at this specific index s, what is the value at change indices? So this will be 2. Now 2 is nothing but change indices of s. This is 2. Now at the index 2 in nums, again remember index 2, when I say by question itself, it actually means index 2, one based array indexing is there. So index 2 in nums, because if they're indexing one based 1 2 3, so index 2 is this one. So if I go and query for change indices of s and that value, that is the index of my nums, then that specific value of nums, if this has become a 0, Aryan, how will this become a 0? Because you know the above operation was reducing the nums of I by 1. So maybe what I could have smartly done is I was reducing this value 1, then maybe it has become a 0 now. So if it has become a 0, and at this step if I am choosing to just have a check that bro, this s index corresponding value is 2, which means it is the index of nums. Now this is index of nums. If it is a 0, then bro, please mark it as okay, marked. This is the right ticked, marked. And ultimately I have to tell you that what is the earliest second, which means earliest index S, such that, or yeah, in the range 1 to m, such that all the indices in nums are marked. All the indices in nums are and should be marked. This is the question. If you have not answered the question, please watch this video, because understanding question is very important for this problem. Now, coming on back, we want the earliest second. So, like usually, whenever we want something early, something first, whatever is coming on first, so we will just simply go on and try earliest thing only. So, what I'll do is, I will go and try earliest second. Again, to make it more simpler, I will convert everything to a zero based indexing now. So all my nums are now zero based indexing. Again, you will not reduce the nums itself. So this problem was this, like this problem was, this problem was nums and change indices. So what I did was, I converted everything to zero based. Now I'm imagining my nums is a zero based indexing. My indices is also a zero based indexing, 0, 1, 2, 3, 4, 5, 6, 7. And as you remembered that these value of change indices also represent the index of my nums array. So I have to also replace them. Okay, 1, 1, 1, 1, 2, 1, 1 and 0. So by this I have replaced everything to a zero base, so that I can work on that very easily. Okay, great. Now I will go on, and what I will do, I will be trying. Okay, bro, for the smallest index S, which is, I will just keep on trying. Okay, I want the smallest index, right? I want smallest index X, so I will just keep on trying the smallest indexes. So I'll try this index, okay, S equal to 0. Then I will say, bro, I have two options. I can decrease it or I can have a check. Now, as soon as you hear two options, you might end up thinking, bro, do I have to apply DP? Bro, hold on. First, check what is happening. This is not two options as in to choose. It is, okay, you have two options and two options are different. One you are decreasing and one you are checking. It is not that, okay, one you are decreasing one value and other decreasing other value. It is decreasing one value and choosing other value. So at this point, I can either choose to check, which means I will choose the index 1, or I can, and you can see by default index 1 value in the very beginning is 2, and or I can choose to decrease the value. See, again, checking this value makes no sense. Why? Because, bro, it is this index value, this value is this index value, which means index 1 value is 2, not 0. So even if I have a check, then I will do nothing. I will waste my one chance. Rather than having a check, I should do one thing. Okay, I should reduce some value. Again, I can reduce any nums of I. But right now, let's imagine I reduce nums of I as this one. But Aryan, why did you choose this? Bro, I did not. You can reduce this also. That is the fact which you have to decide how optimally, or like basically you have to decide which one you should actually reduce. Which one you should actually reduce. That is what you have to decide. Aryan, okay, the index is 1. So I know that, okay, index is 1 right now, and I am not checking it, which means I can reduce any value. So why not I reduce value 1? Bro, it is of no sense. What if next is index 0 itself? Or let's say next to next is index 0. Then it would have been much better that if you had reduced your index 0 values, so that as soon as the index 0 would have come, you would have put a check here. Right? Okay, no worries if you still didn't understand, but yeah, we are trying to think how and what values to actually reduce, and it is entirely dependent upon that who is coming earliest. Maybe this right here, I was at S equal to 0, but maybe in future if some value is coming earlier, that depending upon that future value, I have to decide who to reduce now. But yeah, I'm not reducing, I'm just right now guessing. Okay, reduce something now. Okay, because I got to know S equal to 0 will not work. S equal to 0 will not work. So for sure, I will try a bigger value, S equal to 1, because I want the smallest index S, right? Okay, S equal to 1. Then for sure, you had reduced some value previously. Okay, now again at index 1, you have to check, is that a 0? No, bro, it is 1 because of the last step. It is 1. Okay, bro, if it is 1, which means it is not good to check. Okay, reduce it. Okay, I'll simply reduce it. Okay, I did a reduction. I did not have a check at this step. Again, you have only two options. Either you will do a reduce or you will do a check. So right now, for just showing, I'm telling you, is it a good option to reduce or not? Or is it a good option to check? Now I am at index 1, bro. It is 0, bro. Great, bro. It is a 0. Mark it as a check. Okay, it is checked now because at index 1 I am seeing nums value as 0. Great, bro. Great. Okay, move on, bro. Index 1, bro, it is already marked, so nothing to worry about. But yeah, I will not do a check now. I will actually, again, this was the check operation, but otherwise I'm doing a reduce operation. So here I know I have to reduce something, so bro, simply reduce the specific value. Okay, bro, simply move on. Now I am at this specific value. Okay, index is 2, bro. Index 2 is already a 0, bro. Check, bro. Check. Okay, so bro will check here. Now if bro will check here, okay, yeah, bro, it is 0. Okay, simply move on. Now S is 5. Okay, index 1, bro. Index 1 is already 0, bro, but still I know I have already marked it. I have already checked it. So bro, reduce some else value. So I'll reduce my 1, which is 0. Okay, now S equal to 6. I have already checked both of index 1 and index 2. Again, now indexing are 0 based, and later on going forward everything will be 0 based because I have converted everything to 0 based indexing, and I have checked it. So there is no point of checking again. But I can also see I have reduced everything to 0 also, so there is no point of reducing also. So Aryan, are you saying that this was my last step? So are you saying, Aryan, that S equal to 5 was my last or the minimum S? Because ultimately you are saying no, that you want to have minimum S. So are you saying that this S is minimum? Bro, no, because your ultimate question was every index in nums should be checked, which means by this logic only index 1 and index 2 are checked. What about index 0? It was never checked. So you have to wait until your index 0 get also checked. So at this point, even if I do a check or I reduce, I cannot reduce because I have some everything. So I'll do a simple check itself. Although it is redundant check, but I have to do some operation, right? So I will do some operation, but it will not impact my answer because it did not do anything. It did not affect me. But then S equal to 7. Oh, index 0. Bro, index 0 is already 0. Bro, have a check. Okay, I'll do a check. So you saw that you will actually be reaching S equal to 7, which is the minimum index you need to go to actually reduce everything to a 0. So what's the answer? Answer is 8, because this was actually a 1 based because of the question. So we reached index 7, add a plus 1 because the question says indexing is on the basis of 1. So answer is 8. So far you have just thought of, okay, what everything is happening. I just went on and I just have to go and check for everything. So basically here I had two options, either decrease or check. So I just keep on trying. Okay, I have decrease power, and ultimately my main goal is to decrease everything. Now I want to decrease everything. So, and I was confused, bro, who to decrease, because depending upon who will come next or whoever is coming next in my change, depending upon the allocation, I will have to decide whoever to decrease first and all that stuff. So that is very not sure. I'm not sure about that. So I will store the decrease power. I will do one thing. I will store the decrease power, and I will use the decrease power only and only when I know it's an emergency. Aryan, what do you mean by an emergency? I'll tell you. See, emergency is something when you know that he is the last person to actually come to me, which means that if I would have asked you, bro, I have a 1 again, I'm just putting a change indices as a specific indexes. Again, indexes are 0 based. 1 1 1 1 0 1 1 2 and let's say like this. Now I know that, okay, nums value of, let's say, nums indexing are 0 1 and 2. Now I know, okay, nums value let's say is 4, but I know the nums of this is 2, and let's say this is again 2. Although this is not sufficient, but I'm just giving an example. So if you were at here, you know that you should not like nothing is 0, so don't have a check, but reduce something. Reduce what? Depending upon, bro, 0 is coming first. So it is much better that I should actually reduce 0. But bro, then you can also say, bro, 1 is also coming first. Then why not reduce 1? Because bro, you can see last index of 1 is somewhere else. It is somewhere in future. So maybe I can use that one to have a check. But right now, this is the last location of 0. So bro, please, I beg you, bro, please check this first. Which means in this duration, please, bro, reduce my 0 first. 0 first. So for one thing is, okay, I will have to monitor everything, which means I will check, okay, whatever is the last location of my 0, and then based on that I will keep on reducing. Or there's an easy hack. What? Keep the power. Like, you know, the last index of 0 is this, last index of 1 is this, last index of my 2 is this. So I know one thing, that at these locations I will have to apply a check and verify if everything goes well or not. When I say everything, which means, okay, that specific index value should have been reduced to 0 or not. So what I will do is, now I will keep track of the power, that okay, at this, okay, I got one. Again, this was not, again, the arrow ones are the important locations where check needs to happen. Other location I will just assume, okay, I can have a decrease operation here, so I can decrease here, and here. I'm assuming that part. So what I can do is I can keep track of the power. Okay, I can decrease 1 here, so I have a power of 1. Again, I have a power of 1. When I am at this location, I know I have a power of 2, which I have accumulated for decrease, and now I am at index 0. So bro, can I reduce you? Although you know that at a step you can only have a check, either reduce, like either decrease or check, but you have been accumulating your power, which you just imagine, okay, I'm accumulating power, and when in the emergency, which means when someone is coming who is the end person, then I will use that power. Okay, I'll use that power and I will just check if I can reduce everything. Yeah bro, you can reduce him everything. You can because you had a power of 2 and you can reduce it directly. So bro, reduce him, and now your power has decreased to 0. Now you can simply keep on moving forward, and that's how in emergency you can use your power. That is how we can maybe try off that the things, or basically whom to actually give leverage to. Okay, I should give him the priority, that he should actually be reduced. Now many words are coming in picture, and everything will make sense if you will club everything together. Now I know that, okay, I can decrease everything, so I will keep track of the power, and I know who sir is the earliest S. I want to grab that earliest S. So if you want to grab the earliest S, now you will be Aryan, that makes sense, but how will I even know? Okay, by this fact you imagined that this was your final array. You Aryan, you imagine that this is your final array and your S is here, but Aryan, in the question I want to find the earliest S, so I have to actually go and find which S is suitable. So this last index thing which you did, okay, because if you had remembered, this arrow was representing, okay, it is the last index for this array. But if I am saying for this array, which means I'm considering that, okay, I will consider the entire array S, which means I will ultimately be going up till this specific index S. But if you remembered, I want to know what S I can go to, which means if I say my S is, let's say my minimum S is this, so I'm saying, okay, I will go to up till here only, I will not consider them, and in this portion only I will actually be able to check all of these nums of I. So now I have an issue that I have to try for all the S, which means now when I say my S is up till here, which means I'm considering only this specific portion of the array. When my S is up till here, I am considering only this portion of the array. When S is here, I'm considering only this portion of the array. S is here up till this. Again, this portion of the array will never be considered because I want minimum S. When I say minimum S, I want, okay, up till this S, my entire nums should actually become a 0, and that should be checked, marked. Okay, when I say this S, okay, this S should be there, this S should be there. When I say this should not be considered ever. So ultimately I'm saying, if this is my limit of S, or let's say if this is my limit of S, now I know I can keep track of the power. So okay, I know the last index of 1 is this, last index of 0 is, again, this is a problem, this is the exact same example which we have taken. We have reduced, okay, nums indexing are 0 and 1 now, and these indexing are 0, 1, 2, 3, 4, 5 and 6, and 0, 0, 0, 1, 0, 0 and 0, right? So I just modified that specific change. Now I am saying I am always considering, okay, this portion, this portion, this portion, this portion, this portion, and when I've considered some specific portion, now I know that this is the last index which I should make sure that, again, I will forget everything in the right side. I just make sure, okay, this is the last index for my 0, and at this index, which means at this S equal to 4, again, my priorities, my aim is on S equals S index. So at S equal to 4, okay, This is my 0 index last location. This is my 1 index last location. And these all I can use for my reduction or power. I can use that for my decrease thing. So I know one thing, that I will keep track of the last index, which are these indexes. For all the, okay, for 0, last index is 4. For 1, last index is 3. So I'll say for my 0, last index is 4. For my 1, last index is 3. So that I know, okay, at this point I will have to reduce. I will have to, and how to reduce? I simply keep track of in the power itself. So when I'm here, here and here, I simply kept on accumulating the power. Okay, now my power has become a 3. So I can have 3 reductions. Now I know that where's my nums. So if I am at this, I know this is the last index. So I have to apply a check. If I have to apply a check, I know at index 1, I have to make it as 0 itself. I'll go to index 1. I can make it a 0. Yeah, bro, you have 3 power. Okay, use the entire power 3, and now my power has remained to 0. Okay, but this is done. This is done. Now I go on to this, bro, 0, index 0. Okay, bro, index 0, and I have to have a check because it is the last index. So, bro, if I go and have an index, my power is 0, bro, and I want to have 1. Sorry, bro, this S will not work for you. Increase your S. Okay, I will increase my S. Now my S has increased. Now my last index of 0 has become this. My power also, and my last index of 1 has become this specific index. Again, the same way will go, but you will see here, if you had remembered, my power had become a 0, but you know that this next index 4, which means S equal to 4, is actually free index. It is not the last index. So I can go and increase my power again by 1. Now I'll go on to my S equal to 5. So what will happen? It is the last index. Bro, go and have a check at S equal to S at index equal to 0. So I'll go and have a check. And yeah, bro, this time I have a power of 1. My value is 1. I can reduce that. Yeah, bro, I can reduce that. So you saw, simply I reduced my value, and now every of the values has been reduced to 0. So you can just keep track of how many values are reduced to 0, and say that, okay, keep that in a count variable, count or complete anything you want. And ultimately, if your count has reached the end, voila, bro, you have reduced everything. You have reduced everything at the earliest second, because you are trying, again, if you remember, you are trying for every piece of second. S equal to 0, S equal to 1, S equal to 2, S equal to 3. You are trying for every second. S equal to 4, S equal to 5, and then S equal to 5. You were able to reduce everything to a 0 and check it out. So by this, you know that, okay, as you saw, that you are going on to all the indexes S equal to 0, and that index, you are grabbing that portion of the array and then applying the operation of grabbing the power and reducing the power. So, okay, this operation in which you are going on to all the indexes of S, it is nothing but O of M, because my length is O of M itself. But at specific S, at some specific S, you remember, right, what was happening? Ultimately, you were going and tracking. Okay, firstly you will go, okay, let's say if this was your specific S, again, to go on to all the S's, it is O of M operation. But I am right now saying, okay, I am at this some specific S. If I am some specific S, then I will have to firstly go and find the last index of every index. So I will go and say, okay, last index of 0 is this, last index of 1 is this. When I have found the last index, which is for sure, again, will take O of what? O of M time it will take. Now, if I have done that portion, I will simply go and have a check that, bro, you are simply going. If it is not a last index, bro, keep on increasing the power. If it is last index, reduce the power depending upon what is the original value of nums of I. Okay, bro, I have power of 3, I can reduce that, it becomes a 0. If something becomes a 0, increase your completed or count by 1. Okay, bro, my count has increased to 1 and my power has become a 0. Now, again, index 4, it is, sorry, S equal to 4. Oh, it is not a check location, which means it is not a last index. So my count has been 1. I'll increase the power also by 1, because I can now use this power in future. Now, S equal to 5. Oh, bro, it is last index. So, bro, simply go on and check. If I simply go on and check, I'll simply go on and say, oh, value required is 0. Sorry, value requires 1 at index 0, and I have also power of 1. I'll simply use that power and make it a 0. Make it a 0. Count has become a 2. Earlier it was a 1. Oh, count 2. and I can simply, if I keep on moving my s has completed, count is 2, and ultimately I wanted to make 2 elements because my n was 2. So if count is equal to your n, voila bro, it is your answer, which means this is the minimum index. So ultimately you saw that this will take O of m time, and now to simply go and have a check in your entire thing, it will again go and take a O of m time for you to go and have a check in your, like, because you will simply again go and iterate on the entire nums up till that specific point, and also you will keep on checking your nums of I. So that will take O of m time. Right now you will see that it will become a O of m square, m into m time. It will be O of m square, and you can simply see that your m will simply work. Your m square will simply work. That is not an issue. But you can actually improvise that. On what point, Aryan? Because again, if you come back and look, you can improvise on what point. You can simply see that one part was you are going on to all the indexes, which means s equal to 0, 1, 2, and so on and so forth. And when you have some specific index, then you will take that specific prefix array and then have a quick check by keeping track of the last index and the power, that can you solve or can you make all the elements 0 in your nums by the specific prefix of your string of length m. So that portion might end up taking that portion, which means checking that might take time, and I don't think we can actually do something, or maybe we can do something, I don't know. But one thing I'm for sure is I was going sequentially and I was trying to search for an index which will give me the best, which will actually start solving. Because see, if index was 0, it was not solving my answer. It was not solving. It started solving. And as I go on and have more s, for sure I will have more bandwidth to increase my power. So for sure I can always do right. So you know, it is a pattern: wrong, right. When the search is looking something like this, then for sure we can do one thing: we can apply a binary search. So what I will do is, I will simply, rather than doing a linear search on the index m, I will do a binary search on the index, and the index here is s, which is the seconds. And for sure your that time will be still O of m, so it will be nothing but O of m into log m itself. Now have a quick recap of what and how that will be done. Again, the exact same thing as I showed you, that in the very beginning you will try again. This will be binary search, which means this binary search will say, okay, your s is, let's say again, your s has many values. Okay, this is your change indices array. So my s is equals to 0, 1, 2, 3, 4, 5, 6, and so on and so forth. Let's say so on and so forth. Now your binary search will actually point you to some specific index. Let's say this is a mid. Now if this is a mid, you know that okay, this is a mid, so you have to go and try for this specific portion as your main array. So now your array has become that, okay, this is your array because it's a binary search. This is your array. Now go and simply, okay, from index 0 to index 4, this is your array right now. Go and check if this specific portion or the prefix of the array can actually solve your problem. Solving the problem is making all of them as checked, and that can be checked only when all of them becomes 0. So I'll simply do the exact same funda that I will keep on. I know, let's say my last mid was up till here, so I know that I will never go in this portion, in this entire portion which I was doing. So again, stepwise, if I show you, it was step 1, step 2, step 3, step 4, step 5, step 6, step 7, and step 8, which we saw in the very first example. Now if my mid has been at this index, let's say index 5, then I know that my last steps, it will never be counted, right? So I know that my prefix array is this portion. Now if my prefix array is this portion, so I know this, to find this mid, it takes log of n time, sorry, log of m time, m. Now to find that prefix is validating the answer or not, I will go on and try. Okay bro, firstly remember, you have to go and find the last index. I know this is the mid, so this is the array which I was expecting. So in that, the last index of 1 is this index, and last index of 2 is this index, which is this specific index, right? Remember, this is the array which I am looking for right now. So last index is this. Again, forget these bars, forget these bars, because my final bar is this bar itself. But I know my last index of 1 is this, and last index of 2 is this. So apart from these two indexes, every index I will keep on increasing my power. Okay, remember, this is the last index of 2 and this is the last index of 1. Apart from this, all indexes keep on increasing power. I am at this specific index. Okay, bro, increase the power. Okay, bro, I am at this index. Again, bro, increase the power. I am at this index. Okay, bro, increase the power. I am at this index. Okay, bro, increase the power. Sorry. 3, 4. Okay, now my power has increased to 4. Now I am at this index. Bro, it is the last index, bro. No worries, bro. If it is the last index, simply go on and check what's the value. Bro, value at index is 0. Bro, value is 0, bro. Simply, you have sufficient power, bro. You don't need to get the 0 power. You can have a check. Okay, after doing a check, simply go on. Again, I have done a check, so I will not increase my power because I cannot increase my power. I can do either a power increase, as in the power increase just to make sure is I am reducing a value. So either I can do a power increase or I can do a check. Here I did a check. So because it's the last index, so I have to do a check. There's no option for me. I have to do a check. Okay, bro, simply move on. Now, okay, bro, it's the last index. Okay, bro, no worries. Chill on, bro, chill on. Index is 1. Index is 1. Index is 1. Value is 2, bro. I have a power of 4, which means I can reduce 2 for sure. Okay, bro, reduce 2. Remaining power is 2 itself now. Okay, power remaining is 2. But bro, array has ended, which means your mid has ended here. Your mid has ended here. But bro, you did not reduce everyone. Still your index 0 is not reduced. So bro, nothing, like no worries, bro. This when you were had a mid of s equal to 5, it will go and have a check. Ultimately, he could not reduce everyone, so for sure he will return a false. Okay, bro. Try for a bigger s, which means your mid will actually increase, which means your low will actually increase. Low will become a mid plus 1. So now you will be actually going and trying for a bigger, higher value. This is how your binary search will work, and binary search along with the searching portion. Okay, binary search along with the verifying, is processing, is completed, all that stuff will work like this. Let's say the code. It's pretty simple. We'll do exactly same stuff as what we saw. Firstly, n and m we have grabbed right here. Now when we have grabbed this n and m, we will firstly, as I showed you, we will make everything as 0 based indexing, because we know the change indices and nums are already 0 based, but the change indices contains the value which are actually the index of nums. So please, bro, reduce those values also. So I iterate on my change indices array. Firstly, I allotted this change indices array to my change indices 0 based array. Again, this is just a copy, but I know I have to reduce the values of this change indices, as I showed you in the beginning also. I'll reduce it. It is by address, so values will be reduces in memory, and as in like it is the original value of this specific array which is being reduced. Now when everything has become a 0 based indexing, now I can simply go and do a binary search on what? On your string change indices, because of s was a 0 1 2 3 up till m minus 1. So I'm doing a binary search on my this specific array. Low value is 0, high value is m minus 1. Again, remember, everything right now is 0 based, answer will be 1 based. So please make sure whatsoever answer you have got, add a 1 in the end. Now, okay, low is 0, high is m minus 1, and by default answer is minus 1. This is a standard template which I have been using so far for binary search. That, okay, while low is less than equal to high, you have an answer. If it is possible, again, possible thing, we will have a separate function for that. If it is possible, then allot the answer as mid and change the high to mid minus 1. If it is not possible, then try for a higher value, which means low becomes mid plus 1. Now ultimately, if your binary search returned some possible value of answer, which means answer would not have been minus 1. So if answer is still a minus 1, so the answer is minus 1 itself. But if answer is something, an answer will be the smallest index s, and you know the index s we have converted to a 0 based index. So bro, please, while returning, add a 1 in the answer so that it becomes a 1 based indexing. Now comes the is possible function. Standard, as we saw, that we have this specific array, we will simply actually iterate on this array up till this index only, which is s. So I will iterate from the index 0 to index s, that is it. And while I'm iterating, I have to keep on collecting the power. But bro, you remembered, you have to also make sure what is the last index of every index itself. What is the last location of every index? So okay, yeah bro, that is very much required. So what I will do is I will have a last vector, or you can also have an unordered map. With that will store me what is the last index for, what is the last location of every index. So I iterate on again. I will only keep, I'll only consider I have the array from 0 to this specific index s. This index s, if you have remembered, it is the mid value, it is the mid. So I am doing a binary search on this portion, so it is the prefix portion. Actual nums length m-1 is somewhere else, so this is the mid portion for me. So I consider this portion, and in this portion I'm finding the last location of the index itself. So I'm going and checking and updating the, okay, for like wherever I'm grabbing, like I'm getting the value, update that, keep on updating it until unless it will keep on updating. See how this works is, if you have a 1 1 2 1 2 2 and 1, so okay, 0 1 2 3 4 and 5. So you will see I is the index, I is this index, last change indices 0 based, it is this specific value 1, and I'm saying last of this specific value is I itself. So I'm saying here last of 1 is 0, but then I'm overriding it. Okay, last of 1 now will become a 1. Okay, last of 2 is a 2. Now last of 1 is a 3, last of 2 is a 4, last of 5 is a, sorry, last of 1 is a 5. So this is their last indexes, which means last index of my 2 value is index 4 and last index of my 1 value is index 5, and this will give me the last index, last location of these indexes. Now as you remembered, I will simply go on in my entire from 0 to s, and then I will just simply have a check. Okay, if some index is not the last index, then bro simply increase its power. But if it is a last index, bro, then you know you will have to apply a check, and when you say a check, you will simply go and apply a check itself. Now a check, which means, okay, if you have the power, reduce the power. But bro, if I don't have a power, okay bro, if the power whatsoever you have so far, if it is less than whatsoever nums value I had at that location, return a false. If not, simply decrease the power. Let's say if the nums value was 2, I'll decrease my 2, I'll remain my 2, and I can say, okay, one of the values have been reduced to 0, so basically 1 is completed, because I want to know ultimately in the end that completed needs to be equal to n, so as to make sure all the indexes, or basically all the values of nums have become 0, or they have become checked, all the values of nums itself, and ultimately this can simply return if completed is equal to n. And that's how you will see that O of m log m is a time, because you will see this operation takes O of m time, this operation also takes O of m time, and this operation will take O of log m time. So the complexity is O of m log m. And space, as you can see, although you can actually reduce the space a bit, because if you remembered, I basically cloned my change indices array just to make the indexes as 0 based. So I cloned that out. So it's the reason I actually took a O of m space extra. And if you remembered, I also am keeping track of the last location of the indexes, so I'm making a O of n space also extra. So O of n extra itself, this you can actually reduce, but you will have to use an unordered map or a vector to keep track of the last location. So O of n space will for sure come, and thus this is the most optimal time complexity space complexity which you can actually achieve. Again, you can actually reduce the space, but yeah, that is not much significant in reduction as you could have it. Cool, thanks for watching. Goodbye, take care. That is I was saying that being like moving from index 1 to index 2, like indexing, which means the value is the index of other array, that actually makes the problem a bit harder than the normal problems. Cool, thank you for watching.